Let's talk about some strategies that will help us to solve this problem here. So the first thing I want you to take a look at is that we are dealing with a similar triangle issue that I demonstrated in class. So this 812 pitch means that for every 1 foot that we travel in a horizontal direction, we travel up 8 inches in a vertical direction. And you can see what that does is it results in a triangle. The triangle is a 12 by 8 triangle. Okay? So if we know that for every 12 inches or 1 foot, we're going to be traveling 8 inches in a horizontal direction, what we can do is figure out how many feet this is representing where the position of the rafter is here. We can count up how many feet does this rafter travel in a horizontal direction, okay? And you're given that information here. It's saying here that this rafter from the edge of the building is traveling 12 feet to the center or the ridge. So what I would do is take the 12 feet that it's traveling. Remember, per foot, we go up 8 inches. If I go 12 times 8, the height here would be 96 inches or 8 feet. Okay, so that helps us. That answers that question. Let's put that over here for the equation so that you can see how you would write that. So if we conclude that there's an 8-inch rise per 1 foot run, we take the 8-inch rise and multiply it times the 12-foot run, and that gives us 96 inches. As we're just basically adding up 12 times 8 inches times 12 is 96 inches, or 8 feet. So our answer over here is 8 feet. Next question. What's the height of the first floor and roof height in total? Well, let's see if we can find that information in the drawing. We do know that this height from here to here is now 8 feet, so we can put that information in. But where here does it show us the height from our first floor to our to that same location? And if we look at this elevation symbol here, TOW stands for top of wall, and this 8 foot 0 3/4 inches is an indication of the distance from the first floor level that we're not seeing here to where that top of wall would be. So the first floor level is usually used as the datum or the 0 point, and so this is giving us a positive 8 feet 0 3/4 inches for that wall height. So now if we add the 8 feet 3/4 inches plus our 8 feet for our roof height, our total would be 16 feet 3/4 of an inch. So I'll put that information in here. Alright, so to solve question 2, we add the 8-foot roof height to the top of wall height provided in the detail, and that's where we got that information. So 8 feet plus 8 feet 3/4 of an inch is 16 feet 3/4 of an inch. Last question, what's the area or square footage of the roof? So what we would need to do is get the length of the entire rafter in order for us to do that. And then once we have the length of the entire rafter, we need to actually know the length of the house. And that information has not been provided. So this question, you can't answer this information without another detail or another floor plan or some other piece of information that tells us how wide is this house. We know the length of the house rather. We know the width of it would be 24 because it would be double the 12 feet, but we don't know how long it would be. We can, however, get the length of the rafter, and once we find that information, or if we make it up, we could be able to figure out the area, or how much space, or the area of this surface right here on the tops of the rafters. So I am going to go through the first part of this question, and then we can pretend that the house is certain lengths, and you'd see how you would multiply that number by that length to get the area of the roof on one side and multiply that times 2 to get the area of the roof total if this was a full gable roof. So just to illustrate what we're talking about here, I will do a little sketch. Okay, this detail right here, imagine that it's coming from where it hits the ridge here, and we're looking at all this part in detail. So this is this edge right here on the roof. Okay, so this is what it would look like three-dimensionally. What we don't know from this picture is we don't know the length of the building this way. But if we did know the length of the building, then we'd be able to completely solve this. What I do need to be able to get, though, even regardless of whether I know the length of the building or not, is if I can figure out the length of this rafter right here. What is the distance from here to here? And then once I have that information, then if I have the length of the roof edge, I can do this value times this value, and you see it's going to give me the area of the shaded orange area here. And I would double that to get the area on the other side if I wanted to get that information for my project. You know, if I was working on a real house project and wanted to know, for instance, the area of the roof so I could order the correct number of shingles. So let's do the math on this. And this is going to end up being a Pythagorean theorem problem. And then I'm going to make up a dimension for the length of the house. Alright, here's how the math works out. You have an 8-inch rise, that hasn't changed. You multiply that times the 12-foot run plus the 1-foot overhang. So that would be a total of 13. So you see we're adding 12 plus 1 foot to get inside parentheses first, and then multiplying times 8 inches, which gives us 104 inches, or 8 feet 8 inches. If you take that 8 feet 8 inches, well, here, rather, let's go this way. This is the Pythagorean theorem. A squared plus B squared equals C squared. A in this case, in this scenario, is the 12-foot run plus the 1-foot overhang, or 13 feet. So what we're doing is totaling this 12-foot run plus the 1-foot overhang, because we need to get the length of this rafter from out here to up here. Okay? So that's A in this scenario. B is equal to the height that we just calculated, and that distance would be from here to the very top of the roof in this case. The first height we did, the 8-foot height, was from the top of wall to the underside of the roof. This is including the overhang, so now we're going from the top of wall to the top of the roof for the height. So we have that extra 8 inches. Now we plug that in. So this would be 13 squared. That's the A is 13, so 13 squared. B is 8.667 feet squared equals C squared. Now since we're both of these are working in feet, let me go ahead and put my foot marks in there because I should have those. What we get is 169 is 13 squared, 75.116889 is 8.667 squared. Add those together to get 244.116889. And then we take the square root of both sides of the equation so that this becomes just C. And then this becomes 15.624 feet. So there's our answer right there. The length of this rafter would be approximately 15.624 feet. So then I could take that number right there and I could say, well, let's pretend that the house is 24 feet long. And we can look to see that this has got a 1-foot overhang on the rake side as well. We can assume that. So if we do that, then it would be an additional 1-foot overhang on both sides. So that would end up being 26 feet for the length of the roof. So I would take this number, (15.624 feet) times the length of the roof, which would be 26 feet in this scenario, and that would give me the area of my one side of my gable roof. So let's calculate that. So it would be the 15.624. So I've got it still in the calculator, times 26. And so the area for one side of the roof is 406.230, and that would be square feet. If I multiply that times 2, then I would get the area of the entire project. So times 2. Now I know the area of the entire roof, both sides. So let's bring that down to here. And this would be total roof area. Okay? That's how you would solve it. So according to the instructions here, you don't have enough information to do this last step, but if you pretended you knew that information, that's how you would solve it.